the concept of built-in functions, recursive function, and as well as Lambda functions. Quite simple. Let us see with the examples. As the name implies, friends, built-in means already available. Okay, just if you consider the appropriate Python, C or C++ or Java, every programming language is having some sort of the built-in functions. Now Python also, okay, just in the documentation of the Python, just if you are making use of this particular docs.python.org, automatically you will be getting this library functions, and it is having absolute, bin, boolean, okay, complex, like dictionary, division mode, and enumerate. Like that, we're having plenty of these built-in functions. So the Python interpreter has several functions and types built into it that are already available, and they are listed here in alphabetical order just for the sake of understanding, just where we can see these particular thing in the alphabetical order. Now, just if you are, how can I make use of that particular built-in function? Directly absolute of -10. We know that absolute is a just it is converting negatives to positive. So -10, even if I'm giving also 10, and minimum of 10 -9 -300. As we are talking about the minimum, obviously it is -9 when compared with all the variables. Maximum. So just we have given some values. Out of those values, whatever the maximum we are having, just it is giving that. And power function, POW 3, 4, 3 power 4. Like length of this machine learning. Okay, automatically it is counting the number of characters in this particular string. So the built-in functions, friends, directly I can make use and I can perform some sort of the activities without any imports. Such kind of the functions are known as the built-in functions. Now, the pre-installed modules, we were talking about these pre-installed modules like with the help of the import, where at times, I want to make use of some mathematical functions or maybe some operating system based functions, maybe some NumPy, maybe some sort of the pandas. Okay, in that particular case, just you can make use of that import statement with the pre-installed modules where you can import those modules and you can work with those sort of the modules. Now, for example, we are talking about the math and random module, friends. And math, just we are having the ceil function, square root, pi value, cos, factorial, power, all these things, all these functionalities I can get by importing the math. Import math. Obviously, you can access all these kind of the functionalities like math.ceil of 5.4, math.square root of 4, math.pi value, math.cos of 1, and math.factorial, and math.power function. So just without deputing or without importing this math, okay, just it is not possible, guys, because in the understanding of these modules are having some predefined functionalities, and if I want to make use of those particular functionality in my program, I can use this module, whatever the module I want. And most importantly, guys, the random module. Sometimes while working with the data engineering kind of the scenarios, I want to populate some numbers. Maybe I want to generate some random numbers. In that particular case, just you can make use of this random module with the help of import random and random. Randomly, I want to generate the numbers and integer between the given range. So this particular random module generates, okay, the kind of random variables, maybe random values like function, floating values or some sort of the integer values. There are some other aspects are there where you can make use, but this particular session is limited to understanding of the module, so that we are talking about these things now. Pretty simple thing, guys, like recursion. What do you mean by recursion? Already we have seen in the beginning of the functions f1. Again, if I'm calling same function within it, this is known as calling the same function by the same name. Okay, the same function call itself. Okay, the function calling is calling by itself is known as the recursion. Now you see here example. So is a typical recursive function until if n less than or equal to 0, I need to print Python. Otherwise, guys, just I want to print n and I want to reduce the value. Suppose 5 if I am giving, first it is checking here less than or equal to 0, wrong. So it go to the else part. First it print the 5. Again, we are calling the recursive function n minus 1. What is the n minus 1 value? N is 5 na? So 4. Again 4 less than 0. False. It goes to this thing printing 4. So 5 already printed. Now 4 it is printing. Now the n minus 1 value 3 and here substitute 3. Again it is checking like that until the value becomes less than 0. Finally it is going to print Python and it breaks the loop. So every time friends, if you see your recursive function, again we are calling the same function within the function. That is what you call the recursion. So a recursive function is a function defined in terms of itself via self-referential expressions. The same function calling by itself. The function will continue to call itself and repeat its behavior until some condition is met to return a result. And this is most important thing, guys, like a terminating condition. I can say this is known as the terminating condition because while running the function, if I am not terminating that, it goes to the infinite loop. Okay, and I want to manage the convention like somewhere I have to stop that execution of the function with the help of this condition. That is what you call the terminating condition. Now the other thing is all recursive functions share a common structure made up of two parts, base case and as well as the recursive case. This is the base case, friends. Base is nothing but the condition I want to check, and then recursive case. If the condition is not satisfied, then it goes to the else part and it is going to execute the corresponding function call. So this is how you can refer the concept of the recursive function, calling the same function by itself, and you have to maintain the terminating condition or base case perfectly. Otherwise, it leads to the infinite loop. Now, some other examples. Okay, just how we are making use of things, factorial calculation and all those things. Have a look on these things, guys. Now, the most important construct in the entire Python functions is concept of the lambda functions. Concept of the lambda functions. Have a look on this, guys. Lambda functions can also be known as the anonymous function because it is not having any name. The function which is not having any name is known as the lambda function or anonymous function. And if I am defining the normal function, so far we have seen there is a definition keyword, but whereas the anonymous functions are defined using the lambda keyword. And if you see the keyword lambda in the definition of the function, then you can say that as a lambda function or anonymous function. Now the syntax, just I am giving the arguments and the corresponding expression. And these functions can have any number of arguments, but return only one expression. The expression is evaluated and as well as they returned. And they are syntactically restricted to return a single expression. And we can use lambda functions as an anonymous function inside other function also. And lambda functions can be used wherever function objects are required. So because functions are also reusable entries, and with the help of the lambda functions, Python achieves these kind of the conventions in the simplest way. Have a look on this, guys. Pretty simple examples. Now, just if you see the first example, understand this particular point. Lambda is a keyword where you can say this is the anonymous function. We have not given any name or definition. We are taking value and we are multiplying with 3. So finally, we are going to store that value in V1. Now, how to call that thing, guys? Because as name is not there now, with the return value only, we are calling V1 of 5, then 5 into 3. Just it is going to substitute the argument in terms of X, and we are getting the value. Similarly, V2 of 10, if I am giving also, instead of X, 10 value will be substituted. As we have seen in the corresponding discussion of the lambda function, I can give multiple variables also, X comma Y, and we are executing this expression as X plus Y. So obviously V3, if I'm saying V3 is equal to X value is 5 and Y value I have given as 10. V3 of 5, 10. 10 plus 5, 15. Now the other thing is, so far we worked with numbers only, but if I want to work with string kind of the data, just to see V4 I am storing as machine learning, and I want to print the corresponding value. Okay, as it is V4, just to whatever the argument whatever the return value I'm having just now, we are using that value. Okay, the outcome value inside the lambda function just as a argument, as it is printing. Now you see guys here, a comma b, two variables I am taking, and a plus and as well as the plus b. Just we are making use of that convention. And v5 is nothing but data science and as well as the big data. So likewise, friends, whatever the functionality or logic I want to perform, no matter whether that is a number or whether that is a kind of the text data. Okay, any kind of representation where you want to simply achieve some sort of the functionality, then you can go ahead with the lambda functions. Now here, one more example to perform the addition of three numbers. It's pretty simple. Three arguments, just the logic a plus b plus c. And we are taking this value add. Okay, so this whatever the variable we have declared here, so as to capture the data item after implementation of the lambda. To this only we are sending the arguments. Obviously, it is implementing the expression and finally the value will be stored with the add. Now multiplication, two variables and corresponding expression. Now we are sending these two values. Now the power function. So just I'm taking the two arguments, m double star n power 1 of 5 comma 3. Obviously, you will be getting the outcome. So likewise, friends, the important aspect here is just the lambda function simplifies the usage of the functionality, and you can make use of the kind of the expressions where which is really helping us to understand the logic. Okay, to implement the logic in the simplest way. But there are certain restrictions, friends. In the general interviews and exams also, we may get the questions like, is there any limitation of the lambda function? Yes, of course, friends. Iteration, conditional, and as well as the exception handling cannot be specified. Because iteration means, guys, if I want to perform the for loop or any such kind of the while loop, okay, the lambda functions are not supported with these things, and conditional statements, and then exception handling. Because lambda functions are the main functionality of that lambda function is to go ahead with the kind of simplification. Again, with that simplified things, if I'm again making use of all these kind of complex aspect, there is no purpose of using the lambda function. So, but whereas they are very useful if I am performing one line function that evaluate the single expression. So in the coming days, friends, definitely I'll uh, give more examples related to the lambda functions. But in this session, I want to give you the basis of these kind of the functionalities so that I'm giving these simple examples. Okay, so that is what these things, guys. And in the next lecture, we'll come up with some other topic. Okay, meet you there. Thank you. Thank you very much.